Welcome to part 2 of our chapter 1 lecture. Now we're going to start looking at units. Yes, units. I know all of you seem to have some aversion to units. It's been my experience over a few years that students just don't like them. But they're really important, and I'm going to show you an example soon here of why they're important. Now, all physical quantities have some unit that goes along with them. And sometimes it's a complex unit, like, well, a simple example is a pound. Okay, a pound makes sense in some contexts by itself, but in other contexts it doesn't, like a pound of hamburger. Now that's a more complex unit, and it's important when we use units to be clear, they tell us what we're talking about. Units tell us what we're talking about. Whether it's a force or a mass or an electric current, units tell us the what. The numbers tell us the how much, but units tell us the what. Here are some physical quantities with their units. So electron mass, proton mass, neutron mass, atomic mass unit, you know, the unit out here, the scientific notation, number of significant figures, all of that's important. Now here's an example of the importance of units, right? You are always worried about the number and you often just completely forget about the unit. So here's a recipe. Any idea what it is? Nope. It's a unitless recipe. It has nothing in it. You can't even begin to tell me what this is or guess at it or have any good idea of what it is, right? No idea at all. Well, let's flip it the other way and take the numbers out, right? Here's the same recipe without the numbers. Cups of white sugar, cups of all-purpose flour, cups of unsweetened cocoa powder, teaspoons of baking powder, teaspoons of baking soda, teaspoons of salt, eggs, milk, vegetable oil, vanilla extract, boiling water. This begins to look like it is probably a chocolate cake, right? When you know the what, you are much closer to the answer than when you just know the how much. All right, and so it's really important that you pay attention to units throughout this semester, because sometimes all you really need to know are the units, right? The units. If you forget an equation but you know the units, sometimes they will help you figure it out. Like if I am moving at 10 meters per second, after 10 seconds, how far have I gone? Well, distance is meters, velocity is meters per second, time is seconds. We want to know how far we've gone. That's a distance, that's meters. So if we multiply seconds times meters per second, we're going to get meters. So if we take 10 meters per second, multiply by 10 seconds, we've got 100 meters per second. 100 meters, pardon me. We've got 100 meters. Meters per second times a second leaves us with a meter. 100 meters per second times, 10 meters per second times 10 seconds gives us 100 meters. And without even having to remember the equation based on the units, we have gotten to a useful answer. All right, on to the next bit.